to talk about using logarithms to solve equations that have exponents in them, because the logarithms and the exponents are opposite functions, like the opposite of addition is subtraction, the opposite of multiplication is division, the opposite of exponents is logarithms. Right? So if you look at the first examples, 2 squared equals 4. If I had covered up the 3 and said, what 2 to the what power equals 8, you could have told me 3, right? Well, logarithms are for when you have like 2 to the x equals 6. Well, 6 isn't a 2 times 2 times 2 times 2 kind of number, so we will have to use logarithms to figure that out. But before we do that, I want to start really simply by just writing exponents as logs and logs as exponents. Okay, so if you look at the color coding here, I've got the base of the exponent is the base of the log. The answer to the exponent problem goes here, and the exponent itself is the answer to the log, because like we keep saying over and over, logs are exponents. The answer to a log problem is an exponent. All right, so take a second and try to write, use the color coding, try to write 3 to the 4th power equals 81 as a log. Remember where to put the base, where to put the exponent, where to put the answer. Good. The answer is log base 3 of 81 equals 4. So if you take 3 to the 4th power, you get 81. That's what that's saying. Right? How about the next one? What would you get there? Good. Right. Log base 5, 25 equals 2. Okay? And you'll notice how I'm saying that. Log base 5 of 25 equals 2. Okay, just to get used to saying the log, the words with a log. Okay, now let's go the other way. Let's take a log and turn it into an exponential expression. So again, the base is here, and the base of the exponent is there. The exponent is the answer, because logs are exponents. Okay, and the result goes there. Okay, so log base 2 of 8 equals 3 would be 2 to the 3rd equals 8. Another way to write it. Okay, log base 12 of 12 equals 1 means 12 to the 1st equals 12. Okay, so that's writing logs as exponents, exponents as logs. What if we are going to evaluate logs? And that means find an answer. Okay, remember that the answer to any log problem is an exponent. So I'm going to set this equal to x, all right, because that's what I'm looking for. And then I'm going to, step 1, rewrite the log as an exponent. So I'm going to rewrite this like we did up here as 3 to the x equals 81. Well, now let's use a little bit of mental math. What number can I, or how many times can I multiply 3 by itself to get 81? Well, 3 times 3 times 3 times 3 is 81. So x, in this case, would equal 4. Okay? Take a second and try these other 4. Okay, so log base 2 of 16 equals x. Then that means 2 to the x equals 16. Well, what power can I raise 2 to get 16? 4. So x is 4, because 2 to the 4th equals 16. All right, the next one, again, set it equal to x. Log base 8 of 1 is an exponential. 8 to the x equals 1. Well, what's always the power when I equal 1? Can I raise 8 to equal 1? Anything to the 0 power is 1. So that means x is equal to 0. Okay? All right, this one's a little trickier, not a ton. Again, set it equal to x, write it with an exponent, okay? Now, the number here is on the bottom of the fraction, but we want the answer to be on the top. So how do we do that with exponents? We make the exponent be a negative, all right? So 1/4 x, I'm not sure what x is going to be yet, but I know it's going to be negative because that's the only way to get from the bottom of a fraction to the top. And right now it's at the bottom of the fraction, but the answer is at the top, right? And then I ask myself, what do I multiply 4? How many times can I multiply 4 to get 256? Well, that would be 4 times. So the answer would be negative 4, all right? And the last one, for this one, you need to say this number, okay? 0.0001, the correct way to say it is 1/1000th, okay? So writing it in my exponent form, it would be 10 to the x equals 1/1000, okay? Now, again, we start with the number on top of the fraction, but it ends up on the bottom of the fraction. So I know in order for that to happen, the exponent is going to have to be negative. And then I ask myself, what do when I multiply? How many times can I multiply 10 to get 1,000? Well, every time you multiply 10, you add a 0. So since I've added 3 zeros altogether, that's 3 tens. So my exponent is negative 3. So 10 to the negative third is equal to 1/1000th. Okay? Now, we're going to talk a lot more about this later, but I just want you to know that these two kinds of logs exist. Common logs are logs with base 10, okay? We don't write the 10, it would go right here, but we don't write it, we just know that it's there, okay? Just like an exponent of 1, we don't write it, we just know it's there. So log base 10 of 100 would be 2, right? Because 10 squared is 100. This is the only kind of log that works in your calculator. So tomorrow or Monday, I guess, we're gonna show you how to switch other bases to base 10 so you can plug them in your calculator. The other kind of log is a natural log. Natural logs are logs with base e. So it would officially be written like that, log base e. But we write it ln for natural log, right? So I just kind of want you to know that those are out there. We will do more work with them later. All right, the last thing gets a little bit confusing, and that is inverses. We said the whole reason we started studying exponents and logs was that they were inverses of each other, and they helped us solve exponent problems. All right, so if you look at this original, I've got two ways that I kind of thought might make sense. So let's look at the first way. So if g of x is log base b of x, and f of x is b to the x, okay, then if I plug f of x into g of x, okay, so I get log base b of x equals x, okay? And the reason that it equals x is, think about what this means. It says log base b means what can I raise b to get b to the x? Well, what can I raise b to get b to the x? X. So the exponent is x. All right, so they see how they've canceled the log and the exponent have canceled each other out. All I have left is x. Okay, that's one way to look at it. Another way to look at it is that I kind of like this one. I like this 8 bigger, so you can tell it's an exponent. There you go. All right, so for this one, we know log base 8 of 4 means there is an exponent out there that I could raise 8 to and get 4, okay? That exponent, when I use it, it's going to give me 4. So because this equals that exponent, then I can raise 8 to it, and I'm going to get 4, okay? The upshot, the thing that you need to know about that, I mean, if it's not making sense, because I know this all looks so new and weird, but the basics is that you need to know right now is that if you have a log and an exponent that have the same base, this is exponent base of 8, log base 8, that they cancel each other out and your answer is 4. Okay? So if I had 7 to the log base 7 of 51, then I would cancel those two. I would cancel those two out. Sorry, here, and I would just get 51. Okay, that's the most important thing there. All right, so tonight, don't worry about doing the inverse part of the homework. Just do the first two sections in that, the first two blocks in that section, the writing as exponents and as logs, and evaluating. And then on Monday we'll get finish up on um, inverses, and we'll add stretching and condensing and the change of base formula. All right.